Now that we've got the spindle trammed, I put the dial indicator back in to check and see how parallel the vacuum fixture is to the axis of travel. So I remounted the vacuum plate back down and ran the dial indicator across it, starting with the 0 here, and 2 thousandths difference here, 3 thousandths there, 4, 3, 2, 5 thousandths here, 8 thousandths here, and 3 thousandths here. So rather than resurface this, which already has grooves in it for the gasket, I think I'm going to turn it over and surface the difference from the bottom side, and then flip it back over. It should be parallel to the axis of travel, and then where I have some small ridges here from the original cutting or surfacing of this vacuum fixture, I'll just barely skim it just to smooth it out. So that's the plan. So let me get the gauges out and get the cutter in. I've got the UHMW fixture turned over and the fly cutter mounted in the spindle, and wrote a short little program to surface. I took the a Sharpie and just made some lines on there so we could see what it's doing. I set the Z0 to the surface right here, so we'll see what it takes off. So let me get the spindle started. I think I'm going to set it around 2700 RPM. That's just a hair over 3000 RPM. So let's give it a shot. Well, I've got the UHMW surfaced on the bottom side with the fly cutter, and it's kind of hard to tell how true it cut, because where the overlap of the cut was, it's like a roughness and then smooth beside it. So I think what I'm going to do is take a 1/2 inch carbide tipped end mill and go back over it and see if we can't smooth it out a little bit. I wish I'd left this side alone now after thinking about it. And just took it off the top, but we'll see what this 1/2 inch carbide end mill will do. I took about 2 thousandths off with the 1/2 inch end mill. Turned out pretty smooth. So I'll turn it back over now. I'll do the same thing on the front side and get it trued up. Okay, here we go. Get ready to clean up the top side. I'm running the spindle about 7,000 RPM and about 70 inches per minute feed rate. Well, it turned out pretty smooth. Now I'm going to go back and recut these gasket grooves, which is going to be a little hard to get lined back up, but I might have to do it by hand, one run at a time. Get that done, put the gasket in, put the aluminum plate back on, and that'll be the true test of how well we trammed the spindle when we use the fly cutter on the aluminum again. Before I put the gasket back in, I took the dial indicator, mounted it back in the spindle, and went back across the surface of the UHMW plate again to see how true we were, and we're within 1 to 4 thousandths parallel to the axis of travel in the Y and the X direction. I was hoping it'd be a little better than that, but we'll see how true it is this way when we cut the aluminum plate. So I've got the vacuum lines hooked back up, the gasket in, and so let me get the plate mounted on here, the vacuum turned on, zero out the cutter, and we'll be ready to start. We're reading about 23 inches of vacuum. This is going to be the last pass. I'm taking about a half a thousandth. I should have left it alone on that last pass. I think it just started rubbing so hard it started moving it off the vacuum. Well, looking at the part that didn't get messed up, you can still see the lines, which is normal. And I can still feel something, but it's not catching my fingernail like like it was before. So I guess the tramming did do a little bit of good. I think part of the reason it didn't do better is because of that fly cutter. It's not the right tool for that. The spindle doesn't have enough power at the lower RPM, and if I go higher RPM, I'm liable to throw the thing out of balance. So all in all, I guess tramming did a little bit of good. Still kind of hard to tell for sure though. But anyway, that's it for this one. I appreciate you watching, and we'll see you next time.